Khushbu Singh from RTMNU College, MSc first year, Department of Physics. I am here to explain branch point from complex analysis. So here, let us see what is single valued function and what is multi-valued function. Because branch points mainly deals with multi-valued function. So what is multi-valued function? Let us take an example. See, y is equals to root x. So what we can write here is y square is equals to x. So for one value of x, let us consider x is equals to 1. Y square will be 1 and y value will be plus minus 1. So what we saw here, if we take one value of x, we got two values of y, that is plus 1 and minus 1. This is called multi-valued function. Means for one value of x, we are getting two values of y. This is called multi-valued function. In complex analysis, multi-valued function creates complexity. So in order to avoid that, we have branch cut. So branch points are the points where the function is multi-valued. To avoid that, we have branch cuts. So today we are going to learn about branch points. So let's see. Okay, so before proceeding, let's see what is the definition of branch points. So branch point is basically a point in the complex plane around which, if it is rotated around that point, if we consider this complex plane and this is origin, okay, and this is my complex function. So if I rotate this function around this origin, if it gives different value, this is z, and if I rotate this function around this origin and if I get another value, that is called multi-valued function, and this point will be called branch point for this function. Let us consider an example. W is equals to z power half, which is equals to root z. Okay, so here z is equals to x plus iy, which is nothing but r e power I theta, right? Here we have considered w is equals to root z, that is z power half. So we consider w is equals to z power half, which is equals to r e power I theta whole power half, which is equals to r power half and e power I theta by 2. So this will be my function z power half, which I have considered, right? So this function z power half, I am going to rotate it around the origin. So here what I will change, theta will be replaced by theta plus 2 pi, because I am rotating this function z power half. I am considering this function as z power half, and I am going to rotate this function around the origin. Therefore, theta will be changed to theta plus 2 pi. So let us see that what we will get, z power half. If I rotate this function around the origin, so what I'll get is r power half e power I theta by 2. This will be replaced by r power half e power I theta plus 2 pi by 2. Let us see what we will get. So what we got here is r power half e power I theta plus 2 pi by 2. So which is equals to r power half e power I theta by 2. I am separating these two terms, e power I theta by 2 plus e power I 2 pi by 2, which will be equals to e power I pi, because 2 will be cancelled out. So this will be equals to into e power I pi. We know that this value will be minus 1. Why? Because e power I pi is equals to cos pi plus I sin pi. This value will be 0 and cos pi value will be minus 1 plus 0. Cos pi is minus 1 and plus I sin pi. Sin pi is 0, therefore we got e power I pi as minus 1. Its value is minus 1. So here what we got is that r power half e power I theta by 2 and minus 1. So the value is minus r power half e power I theta by 2. So what we got is our original function was z power half is equals to r power half e power I theta by 2. This was our original function, but what we got after rotating the function along the origin is minus r power half e power I theta by 2 means its value has been changed. So this is called branch point. Means this origin will be called the branch point for this function z power half. Let us see one example related to branch point. Okay, so we have considered this example number 1. So here we have this function. You can see this function is again multivalued function. So for this, if we want to find branch point, we need to consider the argument under this root value equals to 0. So z square minus 1 equals to 0 and z square will be 1, z is equals to plus minus 1. So this will be the branch point for this function f of z is equals to under root z square minus 1. So next one or two examples will be explained by my friend Sumit Pandey. Thank you.
Hello, myself Sumit Pandey, Department of Physics, MSc first year student from Nagpur University. अभी मेरी फ्रेंड खुशबू जी ने पूरा ब्रांच पॉइंट को एक्सप्लेन करके दिया एक एग्जांपल के साथ. इसी को कंटिन्यू करते हुए हम एक दो एग्जांपल और देखेंगे सिंपल तरीके की और आसानी से हम समझ सकें कि क्या करना है. उसके सबसे पहले हम एक सिंपल क्वेश्चन लेते हैं, एक फंक्शन कंसीडर करते हैं f of z. हमने फंक्शन कंसीडर किया लॉगरिथम का करके कि आसानी से समझ सके. एक लिया log z² minus 4. ये हमने एक फंक्शन कंसीडर किया f of z is equal to log z² minus 4. इससे हमें ब्रांच पॉइंट फाइंड करने के लिए इसका जो आर्गुमेंट है वहाँ पे हमें 0 पुट करना पड़ेगा. हमारा आर्गुमेंट यहाँ पे ये है z² minus 4. तो बहुत ही सिंपल तरीके से यहाँ पे हम z² minus 4 equals 0 पुट करेंगे, उसका थोड़ा आर्गुमेंट फाइंड कर लेंगे. z² minus 4 equals to 0. सिंपल तरीके से फिर z² की वैल्यू है कि z² minus equals to 4 और z equals to plus minus 4 ये इसके ट्रांसफर है सिंपल तरीके से. इसी तरीके से हम एक और कंसीडर एक और एग्जांपल एक और देखें. एक और फंक्शन कंसीडर करते हैं f of z अंडर रूट z minus 1 z minus इसका हमें भी ब्रांच पॉइंट फाइंड करना है. तो इसके जो अंदर की वैल्यू है ये आर्गुमेंट है उसे हमें 0 पुट करना है. तो इसकी जो अंदर की वैल्यू अगर इसका रूट लेते हैं तो हमें मिलेगा z minus 1 और z minus 2 इसका 1/2. ये हमारा आर्गुमेंट हुआ. इस आर्गुमेंट को हम 0 पुट करेंगे तो हमें मिलेगा z minus 1 z minus 2 equal to 0. ये हमें इसके लिए मिल गया. आर्गुमेंट और इसको हम सॉल्व करेंगे तो हमें z की वैल्यू 0 मिलेगी और एक z की वैल्यू +1 मिलेगी और z की वैल्यू 2 मिलेगी. इस तरह से हमें इसके 3 ब्रांच पॉइंट मिल गए.